So, now, hopefully you didn't have too many problems in terms of the Canvas site stuff, but there were some issues, and I'm going to talk about that as we do these things in terms of multiple choice versus free response kind of questions and stuff. So, but let's go ahead and get started. Now, remember this. Your test for you guys is going to be on Tuesday. Standard, I always try to start the test early, so as soon as I can throw the other classroom that's just before us out, I'll start passing out the test, getting everything set up for you guys, so when you come in here, you're ready to go. But I do want to make a couple of straight comments about that. You know, this is another a directive coming from the math department for obvious reasons. The first thing is this. When you come in to take the test, you should go ahead and be prepared to take the test. That means your pencil and your calculator out. This is what they call a calculator active test. You know, you definitely want your calculator for this type of test. So you can use the calculator the whole thing. However, no cell phones. Your cell phone should be put away. And I'm not meaning just put it in your pocket or something like that. You should put it deep down in your bottom of your book bag. Also, if you're one of these folks that happens to have one of these iWatches or whatever the case may be, you're going to have to take that crap off and stick it in the bottom of your book bag too. We've had more incidents around here, and including one of my own class, of students using their cell phones and iWatches and all this other stuff to take pictures of the exam and send out open questions to their friends to see if they can get help on the test and stuff. Well, we call that cheating where I come from, and when you get caught cheating, you get thrown out of the university. So I had to throw somebody out of the university for this. Don't cheat, don't be, and so when we see a cell phone out and during a test, we automatically assume you're cheating. Whether you are or not, or your mom texted you a message about something, don't care, you're not supposed to be looking at your phone at all. So you've got to put it away, and before you even come into this classroom, because the math department is going to have basically a policy of not just no cell phones, but if we see a cell phone out or for any reason during the test, you automatically are going to be assumed you are cheating on the test, and your exam will be removed, ripped up into little bitty shreds, and thrown out of the classroom. Okay, so now that I said that, so go ahead and be prepared for putting your cell phones away, and if you got one of these weird iWatches or whatever, and put that stuff away too. You don't need any electronic devices except your calculator. The test looks very much like this. So let's take a look at this thing. First question was this guy here. Find the domain. You know, we had all that chapter 3.1, 3.2 review on exponentials and logarithms. So you're going to see a lot of that stuff. And if you get in here a little bit late, make sure you go back and pass your homework set, the free response part up to Katrina in the back there. All right, so the first one is domains and ranges and stuff. So I got f of x is equal to 2e to the x plus 1 plus 3. Well, first off, with an exponential function, remember, you can have anybody you want to. Negative, positive, zero. Anybody can be an exponent, which means your domain on a problem like this is going to be all real numbers, negative infinity to infinity. The problem with exponentials is this. When you chunk numbers into exponents, you always get positive numbers. So if I look at this guy, we all know what e to the x plus 1 looks like, what e to the x looks like. It's your classic exponential that goes through the point 0, 1 and blows up. However, when you have that plus 1 is going to have it shifted slightly left 1 unit. Times 2 is going to stretch it twice as big, but what is that plus 3 going to do for me? Move it up 3 units. So when I look at y equals 2e to the x plus 1 plus 3, that plus 3 moves it up 3 units. This graph's been shifted left 1 and then twice as big. So this is pretty much my general shape of this guy. But what's the range? The range is the only time you tell me any kind of information about the y coordinates. The y coordinates are from 3 up. So the range is from 3, not including 3 because you never quite hit that asymptote there, 3 to infinity, which makes the answer C. Does that make sense? And this is all college algebra review stuff you should have learned in high school and stuff. It's the review section. That being said, similar question here, state the domain and range of the logarithmic graph. G of x equals negative 2 natural log of x minus 1 plus 3. Well, first off, let's talk about the domain. When it comes to logarithms, remember, you can't take the log of a negative number, nor can you take the log of 0. You can only take the log of positive numbers. So in this case, we're taking the, in this case, natural log of x minus 1, so that x minus 1 must be strictly greater than 0 for you to be able to take a log out of it. Solving for x, that's pretty easy. X has got to be greater than 1. Interval notation, that's from 1 to infinity. So pretty much, there's only one answer for that one. The answer's got to be A. Okay, but let's talk about the range for a second. When you graph this thing, remember a log graph goes to the point 0, 1, and then, goes to the point 1, 0, and goes straight down and goes straight up, because right there at the x-axis is 0. You can only plot positive. So this is the graph of y equals natural log of x. But minus 1 is going to shift it right 1 unit. So this thing is going to move right 1 unit. Negative 2. Negative is going to flip it upside down and stretch it out by a factor of 2, and then plus 3. This thing's going to look like this. It's going to be over 1. It's been shifted right 1 unit. It's upside down and twice as big. And then plus 3. So 1, 2, 3. It's going to come up here and look like this. But what's the range? The range of all logarithmic graphs. It goes up, it goes down. This one's upside down, so it goes straight up. It also goes down at an angle, but it keeps on going down. So the range on all log graphs will always be all real numbers, negative infinity to infinity, which clearly makes the answer still A there. Does that make sense? Again, algebra review at its best. This one, I put this one on the test because I've seen this problem so many times on old final exams, and I want to make sure that you guys are familiar with it. It's just basic, it's algebra review on finding the inverse function. There's no calculus, we're not taking rid of anybody or anything like that. We just want to find the inverse function. But this rational expression that we got here, this rational function, is the one where you got to actually play the algebra on. So this is the one they love to give on old final exams. So, step 1, graph it. Make sure it's a one-to-one function. If you graph this thing, you'll see that x equals 4 is a vertical asymptote. It has a horizontal asymptote at y equals 3. And then this graph actually looks something like, I believe it goes straight up this way and goes down over something like this. And you'll notice that any horizontal line, you can graph the thing, is going to basically only intersect one time, which means this thing is definitely one-to-one function, which means this guy, rational expressions, have an inverse function. Step 2, that was step 1. Step 2, replace function with y. So you can get y equals 3x plus 2 over x minus 4. Just to let you know, if the function was not one-to-one, like y equals x squared or something or other, the official answer, it does not have it does not have an inverse function. That's the key, not an inverse function. Everything has an inverse if you just switch the x and y coordinate. But if you could actually solve for y, well, that makes it even extra special, called an inverse function. So this one, step number 3, is all about inverses. This is where you switch the x and y coordinates. You get x is equal to 3y plus 2 over y minus 4. Step 4 is the hard one, solve for y. I'm going to multiply both sides by y minus 4. I'm going to get x times y minus 4 is equal here. The y minus 4's cancel. 3y plus 2. I'm going to distribute. I get xy minus 4x equals 3y plus 2. If I'm going to solve for y, I'm going to pull all my y's to one side. So I'm going to subtract 3y and at the same time add 4x. So I'm grouping together like terms. Y's go on the left, non-y terms on the right. So this ends up canceling here and here. So I get xy minus 3y is equal to 4x plus 2. Now I've got multiple terms with y in it. I'm going to factor out the y. That leaves me x minus 3 equals 4x plus 2. And then I'm going to divide. Y equals 4x plus 2 divided by x minus 3. And then step number 5 is the inverse step. Replace the function, which this guy was called k of x, with its inverse. K inverse of x is equal to 4x plus 2 over x minus 3, which makes my answer D. Does that make sense? This is a great problem, and notice how I did the algebra on solving it. But just like on your test, I'm not going to put that many algebra questions because, I mean, we keep doing algebra even after all this calculus when we have to take derivative and then go solve something or other. So you can probably anticipate something like this, about, I don't know, 3 questions on algebra. Logarithmic stuff, you know, domain range, things like that. But you'll notice the next one, This one's a formula, and this is the one that, amazing to me, as many times as we went over it, students tend to forget the formula. So let's write it down. This is that famous, the inverse of the derivative of an inverse. We're trying to take the derivative of an inverse, and the formula is this. F prime, F inverse of A prime, the derivative of an inverse, is equal to 1 over F prime of F inverse of A. That is the formula that you need to know on doing the derivative of an inverse function, which is what they're asking you here. So in this problem, they're asking me what is the F inverse prime of 5. According to my formula, that's 1 over F prime of F inverse of 5. To do this problem, you've got to work inside the parentheses first. To remind you, when y is equal to f of x, in terms of the world of inverses, this is the same thing, equivalent to f inverse of y equals x. So when I see f inverse of 5, I know that y is equal to 5, and my goal is to figure out what the x coordinate is. Okay? So, my function, which is y equals f of x, is equal to x cubed plus 9x plus 5. The y coordinate is 5. So I get 5 equals x cubed plus 9x plus 5. And this one is just like web work. We don't want you to think too deep on trying to solve for x. It's usually pretty easy. What number, if I plug it in for x, and I go something cubed plus 9 times something plus 5 actually equals 5, the only thing x can be is what? Yeah, 0. It's usually easy. Okay? 0, which means that f inverse of 5, the y coordinate, is equal to x coordinate, which is 0. So cleaning this up, the answer that I'm looking for is going to be 1 over f prime of f inverse of 5, which is 0. So now, I need that given the f of x was equal to x cubed plus 9x plus 5, then f prime of x, its derivative is going to be 3x squared plus 9, which implies f prime of 0 is 3 times 0 squared plus 9, yeah, pretty much 9. So my answer is going to be 1 over f prime of 0, which we discovered to be 9. Answer is D, 1/9. That's the formula that we want you to know, and it's the introduction to the first time of taking the derivative of an inverse. The derivative of an inverse is 1 over the derivative evaluated at the inverse. So, well, again, some of the log properties you need to know. And I call these properties Humpty Dumpty properties because we're going to get you to do one of two things on a log. Take a baseball bat and beat him up into multiple pieces, or put Humpty Dumpty back together again. So here we go. Remember, log properties. Multiplication turns into addition, division turns into subtraction, and powers get to go out front. So in this first problem, notice, and again, this is why I give you guys these homework sets as test reviews, is to read this thing and look at how I worded the question, because you know I'm going to word it very similar on the test. Rewrite in terms of multiple logs of single variables of the log base 3 of 3x squared times 5 y to the 5th divided by z to the 4th times t to the 8th. First rule, multiplication turns into addition, division turns into subtraction. So this is equal to the log base 3 of 3. It's being multiplied, so it comes into plus the log base 3 of x squared plus the log base 3 of y to the 5th. Now, in the numerator, to be in the numerator, you must have multiplied. Multiplication turns into addition. If you're in the denominator, you're dividing by it, and division turns into subtraction. So this will be minus the log base 3 of z to the 4th minus the log base 3 of t to the 8th. Most people want to argue with me about this last step, say, shouldn't that have been a plus? No. The reason why? Yes, locally you are multiplying, but don't look locally, look globally. That t to the 8th is located where? Denominator. Denominator means divide, divide turns into subtraction. Locally, yes, it's a plus, but then I had to put parentheses around local. I don't want local, I want global. It's in the denominator. Division turns subtraction. But we're not done with our properties. Powers get to go where? Out front. So these guys have power, so this will be 2 log base 3 of x plus 5 log base 3 of y minus 4 log base 3 of z minus 8 log base 3 of t. But there's one more guy with the constant. We had a property, log base a of a. When you take the log base a of a itself, what do you always get? 1. Also, we got the property log base a of a to the x. You get the exponent x. Remember, logarithm solve for exponents. So here, this log base 3 of 3 is actually 1, and there's only one of them that have 1 that's for the answer, and the rest of this stuff does line up. The answer is B. Yeah.
So I guess I'm just a little bit confused about how, because like the wording was in form of single variables. So
yeah,
the idea of like a single variable was the x. That's why I left the 3 with the x squared.
Well, 3 is a constant. Always clean up the constant. But the variable of x squared, the single variable is x. The y to the 5th, the y popped out, and that's why it's y. The z and the t, all these are quote unquote logs of single variables. That's where it comes from. All right, Humpty Dumpty, multiple parts, now putting back together again. Rewrite as a single logarithm, and again, focusing on the words, because these are the same similar words that I know they use on the final exam, hence I'm going to try to use the same words on my test to get you guys kind of well prepared for my test as well as the final exam. I got 2 natural log of 4 minus 4 natural log of x plus 1/2 natural log of y minus 4 natural log of z plus 6 natural log of w plus 3 natural log of t. All right, first deal is this. Now we're working backwards. When we're going to combine logs, addition turns back into multiplication, subtraction turns back into division. These are the big properties. But to be able to combine logs, the coefficient in front of the logs must be a 1. That was our property. So if you've got numbers that are in front of the logs, they got to go back where they came from, which is where? Exponent. So the first thing I'm going to do is anytime I see a number in front of the log, I'm going to put him back as the exponent. So this will be equal to the natural log of 4 squared minus the natural log of x to the 4th plus the natural log of y to the 1/2 minus the natural log of z to the 4th plus the natural log of w to the 6th plus the natural log of t cubed. Does that make sense? All I did was stick the powers up back in the exponents. Now I'm going to turn it into one big log. This is all, they all have to be the same log. This is a natural log. Now here's the rule. Addition turns into multiplication, and multiplication shows up in the numerator. Subtraction turns into division, and division shows up in the denominator. So all I got to do is keep up with what sign is it. What's the sign of this natural log of 4 squared? Positive, understood to be positive, so the 4 squared shows up on the numerator. That's a minus. So with the minus, the x to the 4th will show up in the denominator. This one's a plus, so the y to the 1/2 will show up in the numerator because addition turns into multiplication. Multiplication shows up on top, numerator. That's a minus, this is why I messed them up, so that z to the 4th will show up on the bottom, division. That's a plus, so the w6 shows up in the numerator, and that's a plus, so that t to the cube will show up in the numerator. And just to make him look good, let's clean up my numbers. 4 squared is what? 16, and then make it look like my answers. 1/2 of power is a square root, so that would be the square root of y times w to the 6th times t cubed over x to the 4th, z to the 4th. Does that make sense? So it's the natural log of 16 square root of y, w to the 6th times t cubed divided by x to the 4th divided by z to the 4th, which is, which one of these answers here? I believe the answer is, does that make sense? Questions? Again, because it's review, good practice. Solve 500e to the 3x plus 2 equals 15,000. Well, notice I did not put the answer in terms of decimal, so this is not a calculator problem. Solve for x. Where's the x located at? It's the exponent, in this case, of an e. So the first thing you want to do when you're solving for a variable is locate where the variable is and get that sucker by himself. The variable is in the exponent on the e, so I want to get that e to whatever by himself. So my first move is to get rid of that 500. It's because it's being multiplied times e to the 3x plus 2, so I'm going to divide both sides by 500. This gives me e to the 3x plus 2 because the 500's cancel. 15,000 divided by 500 is 30. Now what kills off e's and brings down exponents? Natural log, so take the natural log of both sides. And this is going to give me the natural log of e to the 3x plus 2 equals the natural log of 30, which the natural log and e's cancel, so you get 3x plus 2 equals the natural log of 30. Solving for x, I would subtract 2. That gives me 3x equals the natural log of 30 minus 2. The natural log of 30 is just some crappy number, but he's closed off with the parentheses, minus 2. And then to solve for x, I'm going to divide by 3. And this gives me x is equal to the natural log of 30 minus 2 divided by 3, which is answer C. Does that make sense? Exponential equations, log equations. I call this one log type 1. I got logs on one side equal to a number. I got log base 2 of x plus the log base 2 of x minus 2 is equal to 3. Mission, solve for x. Well, the only way you can solve for x when you got a log equation with multiple logs is you can only get rid of one log. So you got to combine logs. All these log properties, you got to go back and put them back together again. Addition turns back into multiplication. So you end up getting the log base 2 of x times x minus 2 equals 3. So addition turns back into multiplication. And now you got to get rid of the log. You get rid of log by one of two things. I can use one of our properties. A log base 2, I need to raise 2 raised to that power, and what I do to one side, I do to the other. Or you can do the famous smiley face definition. You remember, if you ever have y equals log base a of x, you can always rewrite it by starting with the base, raising it to the other side. It equals what you're taking a log off. This were our properties. So you can either use properties and raising 2 raised to both sides, or just use the smiley face definition. 2 raised to the third equals this x times x minus 2. We as mathematicians and teachers, professors, love logarithms because I can hide any kind of an equation in a log. So clean them up. 2 cubed is 8 equals x squared minus 2x when I distribute. And I just turned it into a quadratic. Quadratics, you want to set equals 0 and solve. So I'm going to subtract 8 on both sides, and I get 0 equals x squared minus 2x minus 8. And since I made up the problem, you know it's going to factor. So 0 is equal to x. What times what is 8 that differs by 2? 4 and 2. Opposite signs, one's positive, one negative. Since the middle term's negative, the big number's negative. Minus 4 plus 2. Set each factor equal to 0. And solve. I get x equals 4. Add 4 to both sides, and I get x equals negative 2. But remember, check your answers. And you're not checking to make sure you got it right. You can do that too. But with logarithmic equations, you got a property issue problem. You can't take the log of what kind of numbers? Negative. So don't just knock through him because he's negative. Go back to the original equation and check him out. 4. Log base 2 of 4, yeah, that's work. 4 minus 2, well, that's 2, and that's positive, so that's a good answer. Negative 2. Log base 2 of negative 2. Well, that's just bad because you can't take the log of a negative number. So I'm not marking to him because he's negative. I'm marking to when I plug him in. Minus 2 minus 2 is minus 4. I'm taking the log of negative numbers. That's not legal. So the only answer is 4. The answer is D. But how many times have I seen people do this exact problem and they'll circle, actually answer A here every time. I'll see both answers and they just move on because they forgot to check their answers. Does that make sense? Always with logs, check your answers. Here's another type of logarithmic equation. I got 3 natural log of 2x minus 7 equals 9. And on this example, I did it without actually using a calculator, so I didn't put decimal answers on this thing. Now, where's the variable located at? It's inside of this natural log, right? There's a natural log of 2x minus 7. There's my variable. I got to get that log by himself. So my first move is divide by 3. Get the term with the x in it by himself and try to get rid of your constant there. So I'm going to divide by 3 on both sides, and I get the natural log of 2x minus 7 equals 9 divided by 3 is 3. Now what gets rid of a natural log? Raising e to both sides. E raised natural. You can also use the smiley face definition because you know the base on a natural log is e, so you can do that way. But you get the same thing, which gives you 2x minus 7 equals e cubed. Solve for x. I'm going to add 7. That gives me 2x is equal to e cubed plus 7. Then divide both sides by 2, and I get x equals e cubed plus 7 divided by 2, which is does that make sense? Now, another reason why we go over these things for you guys is to remind you of formulas. When it comes to the section 3.4 section, there were several formulas you needed to know. The exponential growth, a equals p naught e to the kt, k would be positive. Exponential decay rates, a equals p naught e to the kt, but here k would be negative. Newton's law of cooling problem, temperature big T is equal to C e to the kt plus Ts, where Ts stood for your surrounding temperature. And then you also had those two formulas of compound interest. You have regular compound, A equals P times 1 plus R over N raised to the NT, and you had compounded continuously. You guys know it better as PERT, A equals P e to the RT. So in this problem, you invested $75,000. That's how much money I wish I had. $75,000, all right? That would be my principal. At the interest rate of 6%. But remember, percentages are for people who can't do math. What is 6%? 0.06. For 4 years. Your time is 4 years. Now, how much money is in the account if it was invested compounded quarterly? N, this is regular compounding, where N is the number of times per year you compound. If you compound quarterly, how many times a year is that? 4. But what you've got to remember, because we're not going to give it to you, is this. Regular compound interest is A equals P times 1 plus R over N raised to the NT. You do have to memorize formulas in Calc 1, and it only gets worse in Calc 2. Plugging my numbers into this thing, this is $75,000 times 1 plus your interest rate, 0.06, divided by N, which is 4, raised to the 4 times your time, which is also 4. So putting it on my calculator, 75,000, I just want to show you what it looks like on the calculator, times 1 plus 0.06 divided by 4, raised to the, and I got the new operating system, so just type in your exponent, 4 times 4. And how much money do I have after I enter it? I'm going to have, and with money, we typically round it to 2 decimal places, $95,173.92. And pretty much answers B. And honestly, if you actually use your brain, which is a requirement of being in college and stuff, you got $75,000. After 4 years, will you have $318,000? Only if you're Hillary Clinton. No, don't think so. $95,000? Possible. $701,000 after 4 years of investing $95,000? Again, you better have some insider trader stuff. This is more like mine. I had $75,000, and after 4 years, I now have $58,000. Stock market didn't go real well for me on that deal, or $94,000. So honestly, there was only really 2 of them that were feasible if I invest in the bank. I should have my money grow and stuff. So think about that. That also being said, look at number 11. How much does it take for an investment to double if an investment at 10% interest compounded continuously? Well, that word, compounded continuously, is screaming to you, which is, what's the formula here? And I should have a question mark there. Compounded continuously is the famous A equals PERT. See, P is the principal. Well, wait a minute. They didn't tell me how much principal I had. It doesn't matter. If you got $1 or you got $100,000, what you're going to be doing is doubling it. So if P is your principal, the amount you're going to get back if you quote unquote double, you're going to have 2P. And watch what happens with the P's. So it doesn't matter. So if you don't like this kind of a problem, well, just give yourself some money. You got $5. Fine. Double it. What you going to have? $10. And you're going to put principal is 5 amount back is 10, and then you're going to solve it the same way, and we'll all get the same answer. So your interest rate is 10%, but again, percentages for people who can't do math, 10% is 0.1 or 0.10. And I'm going to plug it in this formula. Your amount back is doubling the principal, 2p equals PE, your interest rate, 0.1 times t. How long? Clearly the question is time. Solve for t. The t is located in the exponent on e, so I'm going to divide both sides by p, and notice what happens. They're going to cancel literally on both sides, and you get the equation 2 is equal to e to the 0.10 times t. The t is in the exponent of an e, so what am I got to do on this problem? Natural log both sides, and the natural log and e cancel, so I got the natural log of 2 equals 0.1 times t, and then to solve for t, I divide by 0.1 on both sides. So I got t equals the natural log of 2 divided by 0.1, or 0.10 if you like 2 decimal places there. And so natural log of 2 divided by 0.1 is 6.93, and obviously time investment is measured in years. The answer is C. Does that make sense? But in terms of my test, what you guys are going to have to endure next Tuesday is, this is calculus class. So you know at least half this test is going to take derivative of somebody. Look at this next problem. Given f of x equals 3e to the 1 minus x squared times natural log of x, find the equation of the tangent line at x equals 1. Well, to have an equation of a tangent line, so we're throwing back some of this old stuff from chapter 2 at you guys. To find the equation of a tangent line, it's a line I need to have. Well, number one, equation of any line is the point slope formula. Y minus y1 equals m times x minus x1. Anytime I hear the word, find the equation of a line, point slope formula. I got to have two things, a point and a slope. I don't give you any of those things. I gave you half a point. What did I give you? X is 1. So x is 1. How do I figure out the y coordinate? The y coordinate is going to be f of 1, so just plug it in. 3 times e to the 1 minus 1 squared times the natural log of 1. 1 squared is 1, 1 minus 1 is 0, so this is 3 e to the 0 times the natural log of 1. E to the 0 just practice is 1, but what's the natural log of 1 equal to? 0, and 3 times 1 times 0 is 0. The y coordinate is 0, because the natural log of 1 is 0. Things you're supposed to know. But here's the big one. So there's my point. Now I need the slope of the tangent line. You guys have been programmed. Slope of the tangent line is the derivative evaluated at your point. So first off, I got to find the derivative. Remember, this function is 3e to the 1 minus x squared times natural log of x. So what rule am I going to use? Product rule. Derivative the first times the second plus the first times derivative the second. Derivative the first. Derivative 3e to the 1 minus x squared, 3 is a constant. Derivative e to a function, chain rule version, is e to the function, e to the 1 minus x squared times derivative of the exponent, which is negative 2x. The derivative of the first times the second times natural log of x plus the first, 3e to the 1 minus x squared times the derivative of the second. What's the derivative of natural log of x? 1 over x. One of these rules we have memorized. Derivative of natural log of x is 1 over x. Derivative of natural log of function is 1 over the function times derivative of the function. So, but that's not my slope of my tangent line. That is a formula for the slope of the tangent line. So the slope of the tangent line is going to be f prime evaluated at your x point, which is 1. This will be 3e to the 1 minus 1 squared times negative 2 times 1 times the natural log of 1 plus 3e to the 1 minus 1 squared times 1 over 1. Now I got a bunch of numbers over here, but what is the natural log of 1 equal to again? 0, so it's going to kill off all that stuff. So that's 0 plus 3e to the 0 times 1 over 1. X is 1 there, so I can plug in 1. And 1 over 1, which is 1. So e to the 0 is 1. So what do I get for my slope of my tangent line? 3. 3 times 1, which is 3. So I'm plugging into my point slope formula. So y minus y1 equals m times x minus x1. Y minus, here's my point, there's my slope. The y coordinate is 0. Y minus 0 equals my slope, which is 3 times x minus the x coordinate 1. Solving for y equals 3x minus 3. 3x minus 3, answer is D. Does that make sense? Calculate the derivative of this dude. H of x is equal to x squared e to the 4 minus x squared. Now again, on the Canvas site, on the thing, we know that the question for number 13 looked like number 12, but the actual answer was actually for number 13, so hopefully you circled it right. So h of x is equal to x squared times e to the 4 minus x squared. So what rule will I use to take rid of this thing? The old times in the middle is going to be a product rule again. So h prime of x is equal to product rule. Draw the first times the second plus the first time draw the second. So even though we got all these nice new formulas, and don't forget even the arc tangents and all these things you got to have memorized here, I'm still going to be using it product rule, chain rule, and quotient rule. This is product rule again. Draw the first times second plus the first time draw the second. Draw the first. Which rate of x squared is 2x. Draw the first times the second, e to the 4 minus x squared, plus the first x squared times draw the second. Derivative of e to the x is e to the x, but e to a function is e to the function, e to the 4 minus x squared, times the derivative of the exponent. Derivative of 4 is 0, derivative of minus x squared is minus 2x. Of course, you want to clean this thing up, so h prime of x is equal to 2x e to the 4 minus x squared. A positive times a negative is a negative. 2x squared times x makes it an x cubed, e to the 4 minus x squared. So there's my answer, which happens to be A on this particular problem. Does that make sense? So, I mean, trust me, I'm not going to make you do a lot of cleaning up to get the multiple choice answers, but, you know, x times x squared, yeah, go knock yourself out, x cubed. All right. Does that make sense? Okay, there's another one, and here it comes, those arc functions that you guys know. Remember, there's 6 rules, but if I memorize the rules correctly, and remember, every time I take a derivative of a cofunction, including the arc cotangent, arc cosecant, and the arc cosine, they're all going to be negative. So, k of u equals the arc secant of u over 3u plus 2. So to take derivative of this guy, what rule do I have to use? Quotient rule. Draw the top times the bottom minus the top times draw the bottom, all of the bottom squared. So draw the top. What's the derivative of arc secant of u? That's a rule we have memorized. That is 1 over u times the square root of u squared minus 1. Pure memorization. So derivative of arc secant of u is 1 over u times the square root of u squared minus 1. Draw the top times the bottom, 3u plus 2, minus the top, arc secant of u, times the derivative of the bottom. Don't hurt yourselves. What's the derivative of 3u plus 2? 3 all over the bottom, 3u plus 2 squared. Okay? So cleaning this guy up, there's not much cleaning up to do. This one big fraction, so all this shows up in the numerator. 3u plus 2 divided by u times the square root of u squared minus 1, minus 3 arc secant of u all over 3u plus 2 squared. That's pretty much it, which makes my answer which one of these guys? I'm going to check them out. There's always something wrong. Let's see here. There's no extra u in front of this dude because that's not the right formula, so that one's wrong. I believe the answer is this one. Yeah, all the parts are there. Yep, the answer is E. Does that make sense? And again, I tell people this all the time because, hey, learn from my mistakes. Mark of genius here. The fact of the matter is we all make careless errors. What you've got to do in terms of optimizing your time at college and getting those 4.0 GPAs and stuff is wherever you make the careless error, that's where you should slow it down at. I've always been real good at getting the answer. I am horrible at picking them out of a lineup. Sure as anything, when I'm in a rush, I will pick answer A because it looked pretty darn close. And darn close on a multiple choice test just doesn't do it for you. And there's no partial credit, so it's all or nothing. So when I'm on something like this, I will stop down almost to a snail's pace to make sure I pick out the right dude. Calculate the derivative of m of x equals the natural log of 4x cubed minus 2. Now, this is a 10-second question. Derivative natural log of x is 1 over x. Derivative natural log of a function, which is what we got, is 1 over the function times derivative of the function. So m prime of x is equal to, derivative natural log of 4x cubed minus 2 is 1 over 4x cubed minus 2 times chain rule, the derivative of the inside. Derivative of 4x cubed minus 2 is what? 12x squared. Root of minus 2 is 0. So the best you can do on this thing is I can put that in the numerator, make it 12x squared over 4x cubed minus 2. If I really wanted to clean this thing up, I could factor out a 2 out of the denominator and make it 6 over 2x cubed minus 1, but I don't think I did that. So which one's my answer? It looks like D to me. There you go. Does that make sense? All right, here comes another one. N of x is equal to 3x times the sine inverse of 4x squared. First off, pause, hesitate, and ask yourself, what do you see? What rule should you use? 3x times a sine inverse of 4x squared. What rule is that? Product rule. So, n prime of x, remember this is calculus. Labeling is very important, even when showing your work. So, product rule. Draw the first, draw 3x is 3 times the second sine inverse of 4x squared plus the first 3x times drew the second. Well, the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. The derivative of sine inverse of a function is the same thing, but you plug the function in. So that's going to be 1 over the square root of 1 minus the function 4x squared, but then chain rule times the derivative of the inside. What's the derivative of 4x squared? 8x. So in terms of cleaning this up, well, there's two terms here. The first one's pretty set. 3 times the sine inverse of 4x squared, plus here I can combine like terms. 3x times 8x is 24x squared, and I'll put that in the numerator, divided by the square root of 1 minus 4x squared squared. Okay? And I could have also written it 16x squared, but I didn't. I'm just looking at my answers as I'm actually trying to clean this thing up. And so which one of these guys is it? I believe it is 24. Okay, 4x squared. Nope, squared. That would not be it. See, I almost picked that one, but guess what's missing there? So which one's my answer? 3x squared, 24 squared. The answer is D. Does that make sense? We all make careless errors, and you saw me. I almost picked the wrong answer there. It always happens to all of us. Except here's the difference between me and you. I've graduated. They're not going to take away my PhD because I picked out the wrong answer. I got the right answer. Go do it. I just can't pick him out of a lineup. We all make careless errors. Does that make sense? So now it's your time to graduate. So watch the careless errors. They kill. Take a look at this guy. Find dy over dx if y equals the sine of x raised to the x. What do you notice? I got a variable in the base and a variable in the exponent. See, I didn't give you any directions on this. You're supposed to know. Anytime I have a variable in the base and a variable in the exponent, what am I going to use? Logarithmic differentiation. It's the only way you can take rid of this thing. So logarithmic differentiation, we have steps. Step 1, I'll call it S1. Take the natural log of both sides. Natural log of y equals the natural log of the sine of x to the x. Step 2, clean them up. With logs, this is why I have to use logs, because where do exponents get to go? Out front. So I get the natural log of y equals x times the natural log of the sine of x. Step 3, take the derivative implicitly. What's the derivative of the natural log of y? Because we're taking the derivative of the whole thing here. Derivative of the natural log of y is 1 over y times dy over dx. Derivative of natural log of x is 1 over x. Derivative of natural log of y is 1 over y. But chain implicit times, anytime you take derivative of y, you tack on that dy over dx. Equals, to take derivative of x times the natural log of the sine of x is x times its product rule. Product rule, derivative of the first, derivative of x is 1 times the second natural log of the sine of x plus the first x times derivative of the second. What's the derivative of the natural log of sine of x? Well, derivative of natural log of x is 1 over x. Derivative of natural log of function is 1 over the function, 1 over sine of x, times the derivative of the inside. What's the derivative of sine of x? Cosine of x. You're right, I could have written that as cotangent, but I didn't. So, I get 1 over y dy over dx is equal to, cleaning it up, natural log of the sine of x plus x times the cosine of x over the sine of x. Step number 4 is to solve for dy over dx. You do that by simply multiplying both sides by y. And then step number 5 is you go back and replace y with the original function. So I end up getting dy over dx is equal to, parentheses, the natural log of the sine of x plus x times the cosine of x over the sine of x times y, and y was the function sine of x raised to the x. And which one is that? I think I stuck that in front instead of the back. Natural log that, x, nope, that one was bad. Sine of x, natural log that looks like the answer is. Does that make sense? Questions? All right, you know, chapter 3.7, we got a bunch of limit problems for you guys to get to do. First rule of limits, plug it in. Limit as x approaches 0, the sine of 3x over 5x. Well, plug it in. This gives me the sine of 0 over 5 times 0 is 0, but the sine of 0 is 0, it's 0 over 0. So I could do algebra on this thing, but I have no idea what kind of algebra I do, because what major rule did you guys learn in chapter 3.7? L'Hopital's rule, which means to do a limit, all I do is when I have a fraction and I got 0 over 0 or infinity over infinity, I take derivative of the numerator, or derivative of the denominator, and do my limit again. What is the derivative of the sine of 3x? Chain rule. Derivative of the outside, derivative of sine is cosine. The inside, 3x stays the same. Then times derivative of the inside, which is 3. Divided by, what is the derivative of 5x? Just 5. When I plug in 0, I get the cosine of 3 times 0 times 3 over 5. But that's the cosine of 0. And the cosine of 0 is 1. So pretty much I get 3/5. Answer's E. Take the limit as x approaches infinity of 7x e to the 1 over x minus 7x. Well, first rule of limits, plug it in. So this will be 7 times infinity times e to the 1 over infinity minus 7 times infinity. 1 over infinity is 0, and e to the 0 is 1 times infinity times 7. This is pretty much infinity minus infinity. And I told you guys a trick about infinity minus infinity. When you have infinity minus infinity, the trick is either try to get a common denominator or factor. Well, there is no common denominator on this thing because it's not even fractions, but I do have something in common that I can factor out. What do I have in common with this 7x e to the 1 over x minus 7x? 7x. So this is equal to the limit as x approaches infinity of 7x times e to the 1 over x minus, when I factor the 7x out of a 7x, I'm left with 1. Now when I plug in infinity, it turned it into this dude. 7 times infinity times e to the 1 over infinity minus 1. 1 over infinity is 0, and e to the 0 is 1. This is 1 minus 1, so this is 7 times infinity, which is infinity times 0. I went from infinity minus infinity, indeterminate non-L'Hopital rule type, to infinity times 0, non-L'Hopital rule type. But the trick was, with infinity times 0, I got to stick one of these guys in the denominator. What am I going to stick in the denominator? Remember, I got 7 times x times e to the 1 over x minus 1. What's the easiest guy to stick in the denominator? X. Don't touch that 7. That's where most students will screw this stuff up. 7's a constant. We don't move constants at all. Leave them alone. They're happy. They're nice. Leave them alone. So the only terms of functions, I got x and I got this weird e to the 1 over x minus 1. I'm going to move the x to the bottom. So this is the limit as x approaches infinity of 7 times, parentheses, e to the 1 over x minus 1 over, when I put it on the bottom, is x to the negative 1, right? And so when I plug this thing in, 1 over infinity is 0. E to the 0 is 1 minus 1 is 0 times 7 is 0. X to the negative 1, same thing as 1 over x. And plug in infinity, 1 over infinity is 0. It's 0 over 0. Just to let you guys know, this is L'Hopital's rule. So here we go. L'Hopital. This is equal to the limit as x approaches infinity of, 7's a constant. What's the derivative of e to the 1 over x? Well, derivative of e to the x is e to the x, but derivative of e to a function is e to the function, e to the 1 over x times the derivative of the exponent. 1 over x is the same thing as x to the negative 1. So the derivative of x to negative 1 is negative 1x to negative 2. So it's times negative 1x to the negative 2, just to let you guys know. Minus, well, derivative of 1 is 0, and I did that for your benefit. No one cares about it, but it's there. What's derivative of x to negative 1 is negative 1x to negative 2. Minus 0 doesn't matter, but remember I taught you guys, after you do L'Hopital's rule, you got to clean it up. And you're looking to clean something up, and you can clearly see I got strict multiplication division on this thing, and something cancels. What cancels? The negative 1x to the negative 2 cancels on both of them, leaving you with the limit as x approaches infinity of 7e to the 1 over x, because everybody else canceled. And when I plug in infinity, this is 7e to the 1 over infinity. When I plug infinity, I don't write limit anymore. 1 over infinity is 0, 7e to the 0, e to the 0 is 1, so the answer is 7. The answer is C, 7. Does that make sense? Try this one. What is the limit as x approaches 0 on the plus side of x squared times natural log of x? Well, if I'm a betting kind of guy, the answer is 0. Why? Because I've done about 10,000 of these problems, and the answer is almost always 0. So, but you don't know that, so let's just try to do this particular problem. I'm guessing 0. Let's find out. All right, first rule, plug it in. 0 on the plus side squared times the natural log of 0 on the plus side. 0 squared is 0, but what is the natural log of 0 on the plus side? That's something you're supposed to know from chapter 3.1, 3.2. What is that? Negative infinity. It's 0 times infinity. We don't care about the signs of it. Which means the trick is to take this problem, limit as x approaches on the plus side of x squared times the natural log of x, and I got to put one of these two guys in the denominator. Which guy? You got only two of them, x squared or the natural log of x. What's the easiest thing to stick in the denominator? X squared. All I got to do is make the next one negative. So this would be the natural log of x over x to the negative 2. When I move it to the denominator, the exponent is negative. So here we go. Now I'm going to, when I plug it in, natural log of 0 is negative infinity. X to the negative 2 is officially 1 over x squared. Plug in 0. 0 squared is 0 on the plus side, and 1 over 0 on the plus side is positive infinity. It's infinity over infinity, or actually officially negative infinity over positive infinity, which is still L'Hopital rule. So I get to apply L'Hopital's rule to this guy, which is equal to the limit as x approaches 0 on the plus side. What's derivative of natural log of x? 1 over x, divided by what's derivative of x to the negative 2. Negative 2x to the, subtract 1, negative 3. Clean them up. This is equal to the limit as x approaches 0 on the plus side of 1 over x divided by negative 2 over x cubed. Negative exponent goes on the bottom. But when I have a fraction divided by a fraction, I invert and multiply. So lots of algebra here. Limit as x approaches 0 on the plus side of 1 over x times x cubed divided by negative 2. Cleaning them up. This x cancels with one of those, leaving me with 2 left over. So this is the limit as x approaches 0 on the plus side of x squared divided by negative 2. Now plug in 0. When you plug it in, you don't write limit anymore. 0 squared divided by negative 2, that's 0 divided by negative 2. 0 divided by 2, or negative 2 is 0. Yeah, I was right. The answer is 0. If you do these problems a lot, you can catch patterns and look at and see what the answers are before you start. I can do that on lots of these problems. All right, you'll see that actually on the other ones. But remember, no work means no credit. All right, so I had to show you the work to officially get that answer. The test format that I plan on putting together, when's your test? When will I make it up? Monday, that's right. So when I plan on making up this day, it's Easter, I'm not going to do anything. But after this weekend, I'm going to think about the test, and when I'm thinking about it, I'm going to use the same kind of format. So multiple choice, I'm looking at 20 is probably a little much, so probably around 15 multiple choice questions, and then the free response. So let's look at the free response stuff. You know I'm going to put one just like this, because I'm going to drill you guys, and they're going to be hard ones like these, on taking the derivative of these forms that you're supposed to have memorized. This first one, f of x is equal to log a base, what is that, 5, of x cubed plus 9x squared minus 2. Well, derivative natural log of x is 1 over x. Derivative log base a of x is 1 over x times 1 over the adjusting factor natural log of a. So you got this adjusting factor on this one, and this one's going to be the chain rule version of it. So labeling is everything. I'm telling you now because you're going to lose points big time on the test. What's this function called? It's got a name. So it's called f of x. So the derivative is called f prime of x. I'm using the same notation that I did on the last test. Labeling is important. I even take it. Don't forget to label. All right, so equals, what's derivative log base 5 of a function is going to be 1 over the function, x cubed plus 9x squared minus 2, times your adjusting factor, 1 over the natural log of the original base, which was 5. But then chain rule times the derivative of the inside. The inside is this x cubed plus 9x squared minus 2. Derivative of that would be 3x squared plus 18x. And I didn't say clean them up. This is good enough, and I'm real happy with that. Does that make sense? And again, I'm using my derivative formulas and properties and stuff. I mean, officially, I could put parentheses around this guy, but the way I've written it out, it's good to go. Does that make sense? Next one. What is g of x is equal to e to the square root of the cosine of x? Just to let you guys know, I will clean it up. G of x is equal to e to the parentheses, the cotangent. E to the square root of the cotangent of x, so that would be e to the cotangent of x. I don't do square roots. That's raised to the half a power. I just wanted to see if you guys can't agree with this thing. Well, derivative of e to the x is e to the x. Derivative of e to a function, which is what we got, is e to the function times derivative of the exponent. So, the derivative would be called g prime of x. Derivative of e to a function is e to the function, e to the parentheses, cotangent of x, raised to the 1/2 power. But then you got to do times the derivative of the exponent. To take derivative of this exponent, cotangent of x to the 1/2 power, what rule do I have to use? Chain rule. Derivative of the outside, inside stays the same time derivative of the inside. So derivative of the outside, the 1/2 pops out front. The cotangent of x stays the same on the inside, raised to the negative 1/2 power. But then you got to do times the derivative inside of that guy. Here's my $64 question. What's the derivative of cotangent of x? Being a cofunction is what? Negative. And what's the derivative of cotangent of x? Cosecant squared of x. Just wanted to see if you guys know those guys, because you have to for the test. Make sure you know all of them. Just because we haven't used it in about 3 days doesn't mean you're not expected to know it in terms of the test, including the cotangents, the secants, and the cosecants, and all that good stuff. Okay? Look at this one. H of x is equal to the arctangent of x squared times the cosine of x. Things we have memorized. The derivative of the arctangent or tangent inverse of x is 1 over 1 plus x squared. But if you got something other than x, you got to use the chain rule version of it. So derivative of arctangent of a function is 1 over 1 over 1 plus the function squared times the derivative of the inside. So the derivative would be h prime of x. Being it's an arctangent or tangent inverse, is going to be 1 over 1 plus the function, which is x squared times the cosine of x, squared. That's the formula, 1 over 1 plus function squared. But then you got to do times the derivative of the inside. What's the derivative of x squared times cosine of x, and what rule would I use? Product rule. Derivative of the first times the second plus the first times the derivative of the second. Derivative of the first. Derivative of x squared is 2x times the second, cosine of x, plus the first, x squared times derivative of the second. Derivative of cosine of x is negative sine of x. There's my answer. I guess I could clean that up and get minus x squared sine of x, but that's good enough. Because I didn't clean it up, so we'll grade it accordingly. All right. H of x is equal to 5 to the x times secant of x. So because that times in the middle, it's a product rule. So here's another h prime of x is equal to product rule. Derivative of the first times the second plus the first times derivative of the second. Derivative of the first. What's derivative of 5 to the x? Well, derivative of e to the x is e to the x. But derivative of base a to the x is a to the x times the adjusting factor natural log of a. So if you got something other than e's, you got to do the adjusting factor. With logs, you divide by the natural log of the a. With exponentials, you multiply by the natural log of the adjusting factor. So the derivative of 5 to the x is going to be 5 to the x times the natural log of 5. But it's product rule. Derivative of the first times the second, secant of x, plus the first, 5 to the x, times derivative of the second. What's derivative of secant of x? What is it? Secant of x, tangent of x. So secant of x times tangent of x. And there's my answer. Now this next one, use logarithmic differentiation to calculate this thing here. Now, I could do it without logarithmic differentiation, but I told you there's 2 ways you're going to use logarithmic differentiation. One is anytime you got the variable in the base and variable in the exponent, and 2, when they tell you to. They tell me to do this. So logarithmic differentiation. What were my steps? Let's go through it again. Step number 1, take the natural log of both sides. So the natural log of y equals the natural log of 3x plus 1 to the 5th times e to the x divided by 2x to the 5th plus 1 to the half a power, because remember, I don't do square roots. So I took natural log both sides. Step 2, clean them up. So the natural log of y equals, multiplication turns into addition. That'll be the natural log of 3x plus 1 to the 5th plus the natural log of e to the x. And division turns into subtraction minus the natural log of 2x to the 5th plus 1 to the half a power. Keep cleaning them up because powers get to go out front. So this will be natural log of y equals 5. Sorry about that. 5. Natural log of 3x plus 1 plus, what is the natural log of e to the x? Also known as, pretty much x. Natural log and e's cancel. Minus 1/2 the natural log of 2x to the 5th plus 1. Okay? Now, step number 3 is I'm going to take the derivative with respect to x of this guy, and it's implicit because I don't have y equals, I got natural log of y equals. Derivative natural log of y is that 1 over y times dy over dx equals the derivative of 5 natural log of 3x plus 1. 5 is a constant, leave it alone. Derivative natural log of a function is 1 over the function, 1 over 3x plus 1, times derivative of the inside, derivative of 3x plus 1 is 3, plus, what's derivative of x with respect to x? That's trivial. What is that? 1 minus 1/2 is a constant times the derivative of the natural log of 2x to the 5th plus 1 is going to be 1 over 2x to the 5th plus 1 times derivative of the inside, which is 10x to the, don't forget the power, 4, right? Derivative of 2x to the 5th is 10x to the 4th. And so, step number 4 is solve for dy over dx. So I'm going to multiply by y on both sides. And I'm going to go ahead and clean it up as we go. So this cancels here, and I'm left with the dy over dx is equal to 5 times 3 is 15 over 3x plus 1 minus 1/2 of 10 is 5 x to the 4th divided by 2x to the 5th plus 1. All that being multiplied times y. And then the last thing I'm going to do, step number 5, is replace y with the original function. Should have made a bigger box on this one. So I get dy over dx equals bracket 15 divided by 3x plus 1 minus 5x to the 4th over 2x to the 5th plus 1 times, close the parentheses, the original function, which is 3x plus 1 to the 5th times e to the x divided by the square root of 2x to the 5th plus 1. Does that make sense? Logarithmic differentiation. Here's another one. Use logarithmic differentiation. So I got y equals 3x e to the x squared times x cubed plus 5 to the 4th. Logarithmic differentiation. Step 1. Take the natural log of both sides. So I get the natural log of y equals the natural log of 3x e to the x times x cubed plus 5 to the 4th power. But step 2, clean it up. Now this is where a lot of people don't quite finish cleaning up. You'll still get the right answer, but I'm trying to show you guys some easy stuff to do. So cleaning it up. Multiplication turns into addition. There is no division here, so I don't have to worry about subtracting anything. But this is multiply. I got 3 times x times e to the x. So it's times. So that turns into addition. That'll be the e to the x squared. Thank you there. Lost my little square there. Thank you. So, but it's still multiplication turns into addition. That'll be the natural log of 3, including the constant. You can yank him out too. Plus the natural log of x, plus the natural log of, like you said, e to the x squared, plus the natural log of x cubed plus 5 to the 4th power. Now, a lot of people like to put the 3 with the x, but you know, it's being multiplied. You can pull that 3 out with the, so natural log of 3 plus the natural log of x. Does that make sense? Keep cleaning them up. The natural log of y equals the natural log of 3 plus the natural log of x plus natural log of these cancel, so that's just x squared, plus powers get to go out front, 4 natural log of x cubed plus 5. Now, your step number 4 is or step number 3, is take the derivative with respect to x. What's the derivative natural log of y? Catch a pattern. Well, it's 1 over y times dy over dx. But here's the trick. What's the derivative natural log of 3? It's not 1 over 3. Shame on you. 3 is a constant. So natural log of 3 is some crappy number. Derivative of crappy number? 0. Okay? There's no x in it. Plus, what's the derivative natural log of x? Now that's a function. What's the derivative natural log of x? The rule we have memorized, that's 1 over x. Plus, don't hurt yourselves, what's the derivative of x squared? 2x. Plus 4 is a constant. Derivative natural log of a function is going to be 1 over the function x cubed plus 5 times derivative of the inside, which is 3x squared. Solve for dy over dx by multiplying by y on both sides. So this is going to give me, this cancels, and leaves me with dy over dx equals bracket 1 over x plus 2x plus, cleaning this up, 4 times 3 is 12x squared over x cubed plus 5, close bracket, times y. And then step number 5, my last step, is to do what? Replace y. So I get dy over dx is equal to 1 over x plus 2x plus 12x squared over x cubed plus 5 times y, which is this 3x e to the x squared times x cubed plus 5 to the 4th. And I'll write them here so you guys can actually read what I wrote down here. So dy over dx is equal to bracket 1 over x plus 2x plus 12x squared over x cubed plus 5 times 3x e to the x squared times x cubed plus 5 to the 4th power. Here's a classic one. Key to math is catch a pattern. There's a pattern to these guys. All right, take the limit if it exists. Take the limit as x approaches infinity of 1 minus 4 over x raised to 3x. When I plug it in, I get 1 minus 4 over infinity raised to 3 times infinity. 4 over infinity is 0. 1 minus 0 is 1. 3 times infinity is infinity. The famous exponential indeterminate form. So what do we do with this one is, when you got the exponentials, you set y equal to the function 1 minus 4 over x raised to the 3x. This is not logarithmic differentiation, but you do need to take the natural log of both sides. So the natural log of y equals the natural log of 1 minus 4 over x raised to the 3x. And you clean them up. Natural log of y equals the 3x goes out front as a coefficient, and 3x times the natural log of 1 minus 4 over x. So now, put back in your limit, natural log of y equals the limit as x approaches infinity of 3x times the natural log of 1 minus 4 over x. At this point, when you plug in infinity, you get 3 times infinity, which is infinity. 4 over infinity is 0. 1 minus 0 is 1, and the natural log of 1 is 0. It turned into the famous infinity times 0. So once again, one of those tricks is I want to put one of my terms in the denominator. Which one? X, not the 3. Don't touch constants. So the natural log of y equals the limit as x approaches infinity of 3 times the natural log of 1 minus 4x negative 1. I'm going to clean him up because I'm going to take its derivative in a second. Over x to negative 1. And at this point, if you wanted to check it, x negative 1 is 1 over x. That's 1 over infinity is 0 times 4 is still 0. And 1 minus 0 is 1. Natural log of 1 is 0 over x to negative 1 is 1 over x. That's also going to be 0. So this means I get to use L'Hopital's rule. So this is the limit as x approaches infinity of 3 times, what's the derivative natural log of 1 minus 4 x to negative 1? Well, derivative natural log of a function is 1 over the function, 1 over 1 minus 4x to negative 1 times the derivative of the inside, which will be negative 1 times negative 4 is 4x to the negative 2, divided by, what's the derivative of x to negative 1? Negative 1x to the negative 2. But when you do L'Hopital's rule, what happens? Something's got to clean up. What cleans up? X to the negative 2 is canceled. And you clean this up. You get the natural log of y is equal to the limit as x approaches infinity of, clean up your numbers, 3 times 4 is 12, divided by negative 1 is negative 12, divided by 1 minus 4x negative 1 is same thing as 4 over x. So now you plug in infinity. This is negative 12 over 1 minus 4 over infinity. 4 over infinity is 0. This is negative 12 divided by 1, which is negative 12. But that's not my answer. That's the natural log of y equals negative 12. Because you had to do natural log both sides. What gets rid of a natural log? E to both sides. So I get y, which is the actual original function, limit as x approaches infinity of 1 minus 4 over x raised to the 3x actually equals e to the negative 12. And that's my answer. And you can almost see this answer with that negative 4 times the 3 and the exponent stuff. That's where your 12 is coming from. There's a pattern to this stuff. But the answer is e to the negative 12. Does that make sense? Questions? Well, I've got 2 more problems to do, but I ran out of time for you guys, so I'm going to make a part 2 to this video where I'm going to go over these 2 problems as well. So pay attention to your Canvas site, and I'll post both videos for you guys. So study hard. This is a great review for your test. Test is on Tuesday. See you guys then.